Okay, so the question was, does this curve with this parameterization use arc length as a parameter? So what do we have to check? Well, it's actually not hard. All we have to do is we have to check if this magnitude of r prime of t is equal to 1 for all t. So in order to find the magnitude of r prime, that's not particularly difficult. We'll first find what r prime is, and we do that by differentiating each component separately. So we'll get a minus sine of 3t and a cosine of 3t. And now we can find the magnitude quite easily. So to find the magnitude here, we just take the square root of the square of each component. So this first component squared is just sine squared of 3t. Second one is cosine squared of 3t. And by now, hopefully, you've realized this appears somewhat frequently. Our Pythagorean trig identity just tells me that sine squared of an angle plus cosine squared of that same angle is 1. So this r prime of t is 1. Does not matter what t is. We always get the number 1. So this curve is parameterized by arc length. So not a very difficult problem. So the next problem we're going to look at is going to be one where the curve isn't parameterized by arc length. And we're going to ask, well, how do we give a parameterization, a different parameterization of the curve that uses arc length as a parameter?